Good morning, students. All of you welcome for the second part of Towards Green Energy. Okay, this topic we have started in the previous lecture, and we have studied the points in the previous lectures are as follows: that energy and use of energy. In this point, we studied about how energy is important in today's life and how we can use the energy, we can use the energy in proper way, and we can save the energy. Okay, judicial use of energy, stopping over exploitation of the nature. Okay, and moving towards the green energy, which is not causing any kind of pollution to the environment. So we are in the search and we are in the need of such green energy, and the available green energies we have to utilize more and more instead of the traditional energy sources that we are using currently, that causes lot of harm to the environment. So regarding that we have studied. Then after that, some natural energy and natural sources of energy we have started using. Okay, so one of the energy is the water. Okay, water stored in the dam, and when water is released from the dam, it has a tremendous energy which flows down along with the flowing water. So that energy we are using for generating the electricity with the help of magnetic induction motor. Okay, so this magnetic induction motor we are using, and we are producing the electricity. So that magnetic induction motor is called as a turbines. Okay, which generates actually the electricity. And what is magnetic induction? See, there is a use of magnet and copper wounding field. So when this field rotate around the magnet, it generates the electrical energy, it generates the potential difference at two different terminals, that is positive and negative. And in this way, as the turbine keeps on rotating, keeps on running, it starts generating the electricity. Okay, so till now we have studied the water turbine and steam turbine. The water turbine actually is rotated with the help of force of flowing water. Okay, and steam turbine is rotated with the pressurized steam. Okay, so due to that, turbines rotates and energy is produced. Now in this lecture we'll study the another way, another natural resource of producing electricity. Next is thermal energy based electric power stations. Okay, now the thermal power plant that we are going to study is a traditional way of producing energy. It is a traditional way, it is a practice that is made from many of the years, and this causes the harm to the environment. So all of you take a note of it, that this is the traditional way. Okay, and in this type of electricity generation, what is caused? Pollution is caused. Yeah, now let us study the thermal energy based electric power station. The name itself indicates us here we are using thermal energy, means heat energy, for the generation of electricity. Okay, now to produce the heat we need coal. Okay, so coal is burned in the boilers, and what is done? heat is produced, and by using that heat water is boiled, and that is converted into the steam, and then steam turbines rotates and produces the electricity in this way. Okay, yeah, let us study in detail. So as I have shown you the flow chart in the slide, okay, first is coal is used as a fuel because it will produce the heat energy. Then this heat energy is provided to the boiler for conversion of water to steam. Okay, as in the second block you can see water is boiled and steam is produced. Third, steam turbine. Okay, steam turbine, whatever the steam is produced in the boiler is pressurized in the steam turbine. Okay, when it reaches the steam turbine, it starts rotating the steam turbine, and when steam turbine starts rotating, what happens? Generator starts generating the electricity, and this electricity is supplied to the residential area for use. Okay, this energy cannot be stored, okay, because it is in a huge amount, so it is directly supplied. And one thing is important, whenever water is boiled, it is converted into the steam. So this steam is provided to the steam turbine, and steam turbine rotates, and then again that steam that is released from the steam turbine is transferred to the condenser, where it is again condensed back to the water, and that water is again back pumped to the boiler. Okay, this process keeps on continuing. Okay, continuous process. Water is used again and again for producing steam. In this way there is no loss of water also. In this way we can save water, and also we can produce steam. We can use same water for producing steam again, because that is transferred back to the boiler. Only the thing that is, we have to use coal for generating heat energy, and when we burn the coal there is a air pollution because it releases the oxides of sulfur and nitrite. Okay, nitrous oxide and sulfur oxides are released in the environment. It causes pollution. So it is a traditional way of producing electricity, and that we are using from many years, and it causes continuous air pollution. So this is all about thermal energy based electric power station. So this is the way of working of thermal power plant, and energy is produced. Next is flowchart energy transformation in thermal power plant. Now the next flowchart that I have represented over here is the transformation in thermal power plant. Okay, so transformation of what? Transformation of energy, because we have already studied in previous classes that energy can neither be created nor be destroyed, but it can be converted into one form to another. So that energy transformation is shown in the flowchart. In the first block you can see chemical energy in the coal. That chemical energy we are utilizing to burn it and to produce the heat. When heat is produced, okay, to which we call it as thermal energy, that you can see in the second block. This thermal energy boils the water and produces the steam, and when steam is produced it is pressurized, so that produces the kinetic energy that you can see in the third block. It produces the kinetic energy, okay, because when steam is produced itself it has a kinetic energy. That kinetic energy is applied on the turbine, and turbine is rotated. When turbine rotates, it generates the electrical energy. So In this way, we can study the transformation in the energy. And what is the transformation? Heat energy is converted into kinetic energy. Kinetic energy is converted into electrical energy. So there are two transformations that you can study in the flow chart. Okay, so these two transformations occur in thermal power plant. This is the thermal power plant. Okay, actual representation of thermal power plant, which has certain equipments and instruments, okay, and different sections. They are working separately and actually responsible for generation of electricity. So how it is, let us study. First, let us start with the fuel and air. Okay, we need fuel to generate heat energy, and we need air to burn the coal. Now, in the boiler, we are burning the coal, and here you can see a zigzag tube through which water is pumped by the pump. Water is pumped by the pump as shown in the diagram. This pumps the water into the boiler where heat is produced, coal is burned, then it becomes very hot and converts into steam. Okay, this steam is pressurized on the turbine. Okay, you can see a turbine over here. When turbine starts rotating, it generates the electricity by generator. So generator produces the potential difference at its two terminal, that you can see potential difference produced by the generator at its two terminal, that is positive and negative. So this is the potential difference. Okay, now the steam passed through the generator is transferred to the condenser, as you can see in the image. This is the condenser, and steam is passed to the condenser. It goes for cooling in the cooling tower. This is the cooling tower where steam cools down, converts into cooled water. Okay, that is pumped back to the pump, which is pumping the water to the boiler. In this way, water is recycled and reused, and steam is produced, and continuously electricity is produced in the thermal power plant. So this is all about the thermal power plant. Okay, all the information that I told you is summarized in the text, that how thermal power plant is working, which sections and equipments and instruments are there, which are the parts of the thermal power plant, and what is the role of each and every thermal power plant we have studied, that I have just summarized in the text. Okay, how fuel is first of all burned, as you can see over here. Fuel is burned in the boiler. It emits the gas. Okay, gases are released to the atmosphere, which are very dangerous. Okay, and they are released through the high tower that I have represented in the image. This is the high tower. This steam is converted back to the water by taking out heat from it by cooling it. This is done in the condenser using water in a cooling tower. Okay, so all the things we have already explained. You can just read the text and again you can understand. If you have any problem, you can keep asking your doubts. As I said, there are problems associated with the thermal power plant because we are burning coal over there and it releases the harmful gases. As I said, sulfur dioxide, nitrous oxide and all, so causes air pollution. So that I have highlighted over here. Air pollution due to burning of coal. Burning of coal results in emission of gases like carbon dioxide, sulfur dioxide, nitrogen oxide, which is harmful to the human health and also to the other animals of the planet. Along with the emission of gases due to burning of coal, soot particles are also raised into the environment. Soot particles means the halfly burned carbon, which is light in weight, which is suspended in the air and keeps on floating in the air, which increases the dust particles in the air and also causes the air pollution, and that has a bad effect on the health of human. So this may cause serious problem related to respiratory system. And the third problem is the reserves of the fuel used in this method, that is coal, are limited. Therefore, in future, there will be limitations on availability of the coal. As we are using the coal continuously for electricity generation, in the future, what will happen, that there is a limitation for the coal. Once the storage of coal is exhausted, then there is no availability of coal. So we have to find the other sources for generation of electricity. So this is the limitation of the thermal power plant. Next way that we are going to study is power plant based on nuclear energy. In this, we can use the natural resource, okay, which is freely available, okay, but it also has limitations and very harmful effects. But still, this energy is used from many years, and nowadays it is still actively used for generation of electricity. Now, what is this nuclear energy? We'll study. As you can see the flow chart in the slide, it represents first block, nuclear reactor for nuclear fission. So first important section of the nuclear power plant is nuclear reactor for nuclear fission reaction, where actual nuclear fission reaction takes place. Now, how nuclear fission reaction takes place? For that, there is a need of fuel. So fuel used in the nuclear reactor is uranium. Uranium is a radioactive compound which has tremendous energy of radioactivity. Okay, so that is used for nuclear fission reaction, and it generates the heat energy, and depending upon that heat energy, the steam turbines are rotated. So how this happens, we'll study step by step. Second block is system for steam generation from water. Then steam turbine rotates, generates the electricity by generator, and electrical energy is produced. Okay, fuel I have shown you over here is uranium or plutonium. Okay, we have two general ways, two general sources of fuel is uranium and plutonium. Okay, and other system, except the nuclear reactor, the other system is same as like the thermal power plant. So the difference in the thermal power plant is we have used coal in the thermal power plant, and here we are using radioactive compound like uranium and plutonium for generation of heat energy. Thus, here nuclear energy is converted into thermal energy. Okay, thermal energy is converted into kinetic energy, and kinetic energy is converted into the electrical energy. So this is also a energy transformation in nuclear power plant. Okay, as we have studied the energy transformation in thermal power plant, now we'll study the transformation of energy in nuclear power plant. So first, nuclear fission is carried out, nuclear fission reaction, which generates the heat energy, thermal energy. So nuclear energy is converted into thermal energy. Thermal energy is converted into kinetic energy because it produces steam, and steam has the kinetic energy. So now kinetic energy is produced, and kinetic energy is converted into electrical energy. So the transformation in this system occurs is 3 times. Okay, one energy is converted into another, and another energy is converted into again another. So 3 conversions or transformation of energy we have studied in this nuclear power plant. Nuclear energy is converted into thermal energy into kinetic energy into a electrical energy. These are the transformations that occur in nuclear power plant. Okay, now the question is that how does nuclear fission takes place? Okay, so let us understand this, that when we are using uranium as a radioactive substance, how that is responsible for nuclear fission reaction, and how nuclear fission reaction is responsible for generation of heat. We'll study now. So let us study, all of you, the nuclear fission reaction. Here we have used uranium-235 as a radioactive substance as a fuel for nuclear fission reaction, and what we have done, we have bombarded the neutron on uranium 235. Okay, when neutron is bombarded on uranium 235, that neutron is absorbed by the uranium, and that uranium 235 is converted into isotope uranium 236. As you can see over here, 235 is converted into 236. Uranium 236 is isotope of uranium 235. And how isotope is produced? By bombarding the neutron on the uranium. Okay, now being extremely unstable, this isotope is produced is completely unstable. Okay, extremely unstable, and converts into atoms of barium and krypton. It converts into atoms of barium and krypton through a process of fission, releasing 3 neutrons. What first happens? Uranium is bombarded with the neutron. It absorbs the neutron and converts into the uranium 236, that is extremely unstable, converts into atom of barium and krypton, and at the same process it releases 3 neutrons along with the 200 mega electron volt. It is 200 mega electron volt energy. Okay, this is the energy. So this energy is released by this 3 neutrons. How much energy is released? 200 mega electron volt. The 3 neutrons generated in this process cause fission of 3 uranium of 235 atoms, releasing more energy, and this reaction goes on continue, and this is called as chain reaction. Let me show you this in the image. See, this is the neutron and the molecule of uranium. Okay, one atom of the uranium. Now there is a fission between neutron and uranium. When this neutron is bombarded on the uranium atom, then this neutron is absorbed by the uranium 235, and 235 is converted into the isotope of 236. As you can see in the image, uranium 236 is produced. After that, 2 molecules of barium and this krypton is produced. Okay, barium and krypton is produced. These two molecules are produced after the uranium 236 is produced, and there is a release of 3 neutrons. As you can see in the image, let me show you. These are the 3 neutron molecules are released by the unstable uranium 236. So now this 3 neutrons released from the fission reaction again react with the another 3 molecules of the uranium. Another 3 molecules of the uranium 235. Again these 3 molecules of uranium absorb the 3 neutrons and convert into unstable uranium 236, and then this uranium 236 again carry out the same process, produces 2 molecules, these 2 atoms of krypton and barium. As you can see, 3 reactions are going on, and that produces each of 200 mega electron volt energy. In this way, the fission reaction goes on continue, and it produces the heat energy. So this is nuclear fission reaction. Very simple. Neutron is bombarded on uranium 235. Uranium 235 becomes unstable due to absorption of neutron. That is converted into isotope 236. This unstable uranium 236 is converted into 2 atoms of barium and krypton, and also it releases 3 neutrons. These 3 neutrons again react with the new 3 molecules of the uranium 235, and reaction keeps on continue. This is called as nuclear fission reaction. Important power plants of India. Okay, these are the important power plants of India. First is Kundankulam power plant. It is in the state of Tamil Nadu. It is India's biggest power plant. It is India's biggest power plant and produces the energy of 2 gigawatt. Kundankulam power plant in Tamil Nadu produces 2 gigawatt power, and it is a huge power. It is India's biggest power plant. Second is Tarapur atomic power plant in the state of Maharashtra. It produces 1400 megawatt energy. Third is Rawat Bhata power plant. It is in state of Rajasthan, and it produces 1180 megawatt energy. Fourth is Kaiga power plant. It is in the state of Karnataka. It produces 220 megawatt energy, electrical energy. This is the nuclear reactor. Here is actually the place where nuclear fission reaction takes place, and when heat is produced, that heat is used for generation of steam. So here you can see boiler. Okay, whatever this heat is produced, that is transferred to the boiler. Water is boiled, steam is produced, and then steam turbine rotates. Generator generates the potential difference. Again, that water is sent to the cooling tower. Cooling tower cools down the steam into water, and that is pumped back to the boiler through this pump. So this is the nuclear reactor. So what are the problems of nuclear plant? First, the products are fission. Products after fission of nuclear fuel are also radioactive and emit harmful radiation. So when nuclear fission reaction is over, still that waste is radioactive and it emits the harmful emission, radioactive emissions that is harmful for health. The products are called nuclear waste. Okay, it is nuclear waste, and disposal of this nuclear waste is having very precise protocol, and that is needed to be followed safely. Okay, and disposal of this nuclear waste is a very big challenge for scientists. It is a very big challenge. Second, an accident in nuclear power plant can be very fatal. This is because the accident may result in release of very harmful radiation. It can release very harmful radiation, and it cannot be controlled by the human being once the accident happens. Next, we are going to study is power generation of natural gas. Here we are using natural gas for generation of electricity. So the common way of working is same, only the change is fuel that we are using. First we have used coal in thermal power plant, second we have used nuclear energy for generation of energy, electrical energy, and third we are using gas. Here only the difference is gas. Okay, as in each and every type of electricity generation power plant, we are just using different fuels and we are generating the electricity. So here is just gas, and here we can clearly understand that we are using gas. So what we'll do, we'll burn the gas. After burning of the gas, what we'll do, we will boil the water in the boiler and it produces steam. Okay, it produces steam that can be used for rotating turbines, steam turbines. As you can see the flow chart, compressor is used for pressurized air. So that will create the air pressure in the process. Here we have combustion chamber where natural gas is allowed to pass in a combustion chamber for combustion. Then that produces the heat, okay, and pressurize air. So in gas power plant we can use the boilers also, and we can also use the pressurized gas power. So first of all we are using pressurized gas power by the help of compressor, okay, which compresses the produced gas after the combustion, okay, and air also becomes very warm, so that produces the potential. So this pressurized gas is pressurized on the gas turbine which rotates, and generator generates the electricity, and electrical energy is produced. So what is the energy transformation in this power plant? Let us study with this flow chart. Chemical energy we are using in the form of natural gas. Now this natural gas energy is converted into kinetic energy. So because when we burn the natural gas, it produces the pressurized gas that produces the kinetic energy. So this kinetic energy generated due to combustion of natural gas is pressurized on the turbine, and electrical energy is produced. Here is the flow chart of the power plant based on natural gas. This is power plant based on natural gas. So here we are using fuel as a natural gas. We are burning or combusting the natural gas into the combustion chamber, and we are pressurizing the gas on the gas turbine. We are rotating the turbine and we are generating the electrical energy. There is an emission of the gases through the turbine and electricity is generated. Some natural gases, or what we can say, some natural gas based power plants, natural gas based power plants and their capacity in India. First is Samarlkota. Okay, what is Samralkota? Sorry, it is Samralkota in Andhra Pradesh, and how much is the capacity of the plant is 2620 megawatts. Next is Anjanvel in Maharashtra, and it has capacity of 2220 megawatt. Third is Bhavanna in Delhi, and it has capacity of 1500 megawatt. Fourth is Kondapalli in Andhra Pradesh, and it has capacity of 1466 megawatts. So what you have to do, you have to remember the different power plants and the type of power plant. Either it is a thermal power plant, or it is a natural gas based power plant, or it is a nuclear power plant, and their capacity you have to remember. You have to remember the place, you have to remember state and capacity. So that can be asked for the multiple choice questions. So here we end today's lecture. Thank you.